the 18th of March 2026. This is not just another date in space history, it is the moment everything changed. At exactly 6:14 UTC, an object known as 3I, Atlas crossed into Jupiter's magnetosphere, and at that exact moment, a classified signal was released to the global scientific community. That timing was not random. It was deliberate. What scientists revealed in that instant was not a theory, not speculation, and not an early-stage discovery. It was proof clear, measurable, and impossible to ignore. 7 days earlier, the Fermi Gamma-Ray Space Telescope had detected something extraordinary. The data was immediately locked inside a restricted review system at NASA's Goddard Space Flight Center, where it remained untouched publicly while 3I Atlas completed its final approach toward Jupiter. For a full week, scientists analyzed it behind closed doors, verifying every number, every signal, every anomaly. And then, precisely 14 minutes after the object crossed into Jupiter's magnetic boundary, the data was released. What that data confirmed has forced a complete rewrite of everything we thought we understood about interstellar objects. The signal showed that 3I, Atlas, is not just a passive object drifting through space. It is actively powered, and not by chemical reactions, not by sunlight, and not by any natural astrophysical process. It is powered by a controlled nuclear fusion reactor, one that has been running continuously for at least 8 months. This conclusion does not come from guesswork. It comes from gamma-ray spectroscopy, one of the most precise tools in modern physics. When scientists analyze gamma rays, they are not just measuring energy, they are reading signatures, like fingerprints left behind by nuclear reactions. And in this case, the fingerprint was unmistakable. The detected photons were concentrated at exactly 2.223 mega-electron volts. That number is not flexible, it is not approximate. It is a fixed value that corresponds to a very specific nuclear process, the capture of a neutron by a hydrogen atom following deuterium fusion. In simple terms, two deuterium nuclei collide, fuse together, and release a fast neutron. That neutron then interacts with surrounding hydrogen, producing a gamma-ray photon at precisely this energy level. This is not something that can be faked by heat, pressure, or magnetic fields. No natural cosmic process produces this exact signal in isolation. It only appears in one scenario: active nuclear fusion involving deuterium. Now consider the scale of the observation. Over a 6-hour window, scientists expected to detect around 72 background photons in this energy range. Instead, they recorded 847. That is in excess of 775 photons, far beyond normal variation. Statistically, this represents a 28 sigma detection. To understand what that means, the discovery of the Higgs boson, one of the most important achievements in physics, was confirmed at just 5 sigma. This signal is not just strong, it is definitive. And the evidence does not stop there. At the same time this data was being recorded, a completely different instrument aboard the International Space Station detected a rise in neutron activity. Different technology, different location, same time window. Both systems pointed to the same conclusion. Fusion was actively occurring inside 3I Atlas. This changes everything, because fusion is not easy. On Earth, we have spent decades trying to control it. Massive facilities, billions of dollars, extreme temperatures hotter than the core of the sun, and still, we struggle to maintain it for more than short bursts. Yet here is an object, just 2.6 kilometers wide, operating in the freezing vacuum of space, running a stable fusion reaction continuously without any visible infrastructure or heat signature. The implications are staggering. This is not experimental technology. This is not an accident. This is engineering advanced, controlled, and intentional. And as of today, that system has reached Jupiter, the most powerful electromagnetic environment in the entire solar system. The question is no longer whether 3I, Atlas, is powered. That has already been answered. The real question, the one we are only beginning to understand, is what it was designed to do once it arrived. If confirmed that 3I, Atlas, is running a fusion reactor, then the next question becomes unavoidable. How powerful is it, and how is it even possible? Because once you begin comparing what we observed in space to what humanity has achieved on Earth, the gap becomes almost impossible to ignore. The signal from the Fermi Gamma Ray Space Telescope did more than just confirm fusion. It allowed scientists to estimate the reactor's output. After correcting for detection angles, neutron capture efficiency, and surrounding material composition, the numbers converged on a steady figure, approximately 340 kilowatts of continuous power. Not for seconds, not for minutes, but continuously for at least 8 months. At first, 340 kilowatts might not sound extraordinary. It's less than what a small industrial generator produces, but that assumption collapses the moment you consider the environment. This power is being generated inside an object only 2.6 kilometers wide, floating in deep space at temperatures near absolute zero, with no visible heat loss, no radiators, and no external energy source. On Earth, fusion is the most difficult energy problem we have ever attempted to solve. The best example is the ITER fusion reactor project currently under construction in France. It represents decades of global collaboration involving 35 nations and a budget exceeding $20 billion. The goal is to produce 500 megawatts of fusion power, but even that requires maintaining plasma at temperatures over 150 million degrees Celsius. To achieve this, ITER uses massive superconducting magnets generating fields strong enough to contain plasma hotter than the sun's core. The reactor structure itself weighs tens of thousands of tons and spans an area comparable to dozens of football fields. And even then, it will not operate continuously. It is designed for pulses, short bursts of energy lasting only minutes at a time. Continuous operation is still decades away. Now compare that to 3I, Atlas. A compact object, no visible infrastructure, no thermal waste, no massive containment system, and yet it is producing stable fusion energy continuously in the cold vacuum of space. That is not just an improvement. That is a completely different level of engineering. Even more striking is the thermal signature, or rather, the lack of one. Every fusion reaction humanity has ever created produces excess heat. Managing that heat is one of the biggest challenges in reactor design. But 3I, Atlas, appears to operate at temperatures close to 3 Kelvin, just above absolute zero. That suggests something extraordinary. Either the system is achieving near-perfect energy efficiency, or it is channeling waste heat into a form we cannot currently detect. Then comes the question of fuel. Based on the object's composition, which appears to be largely water ice, scientists calculated the amount of deuterium available. Deuterium is a heavy isotope of hydrogen and a key ingredient for fusion. The ratio observed in 3I, Atlas, is about 500 parts per million, roughly 25 times higher than what is typically found in interstellar space. That level of enrichment does not happen naturally. It requires deliberate processing. Someone or something prepared this fuel before the object ever began its journey. And when you run the numbers, the implications are staggering. At the current rate of 340 kilowatts, the available fuel could sustain the reactor for approximately 820 million years. Not decades, not centuries, hundreds of millions of years of continuous operation. That alone changes the way we think about this object. Because this is not a system built for a short mission. This is a system designed to last longer than entire civilizations. It is engineered for timescales that go far beyond human planning or technological cycles. But here is where things become even more difficult to explain. The 340 kilowatt output does not align with some of the observed behavior of 3I, Atlas. Over the past months, the object has made trajectory corrections, requiring bursts of energy far beyond what a system of that size could produce in real time. To adjust the path of an object with a mass estimated at 1.4 times 10 to the power of 13 kilograms, even small velocity changes demand enormous energy. These maneuvers cannot be explained by a steady 340 kilowatt output unless energy has been stored over long periods and then released in short, powerful bursts. This suggests that what we are observing is not the full capability of the reactor. It may only be the baseline, the minimum output required to keep systems running during transit. In other words, 3I, Atlas might not have been operating at full power. It might have been operating in a low power mode, conserving energy, staying hidden, and avoiding detection as it moved through the solar system. And now, everything has changed, because as of today, this object has reached Jupiter, a planet with a magnetic field so powerful that it generates its own massive electrical system. The question is no longer just about what powers 3I, Atlas. The real question is what happens when that system connects to something far bigger. Now we arrive at the moment that changes the entire equation. Because everything we've discussed so far, the fusion reactor, the fuel supply, the hidden energy reserves, was only the setup. The real event began when 3I, Atlas, reached Jupiter. Jupiter is not just another planet. It is the most powerful electromagnetic engine in the solar system. Its magnetic field is roughly 20,000 times stronger than Earth's, and it rotates once every 9.9 hours, generating enormous electrical currents across its magnetosphere. This creates a natural energy system on a scale we don't normally associate with planets. At the center of this system is one of the most intense electrical structures known, the Io flux tube. Io, one of Jupiter's moons, is constantly ejecting ionized material into space due to its extreme volcanic activity. As Io moves through Jupiter's magnetic field, it acts like a conductor, generating an electrical current through a process called unipolar induction. The result is staggering around 5 million amperes of continuous current flowing along magnetic field lines between Io and Jupiter's poles. This interaction produces an energy transfer estimated at nearly 2 terawatts. To put that into perspective, that's comparable to the total electrical generation capacity of entire nations concentrated into a single natural structure in space. And 3I, Atlas did not randomly drift into this region. It navigated to it with extraordinary precision within just 57 kilometers from an interstellar trajectory. That level of targeting is not accidental. It implies intent, planning, and exact knowledge of where this energy source exists and how to reach it. Now compare the numbers. The internal fusion reactor of 3I, Atlas, produces about 340 kilowatts. The Io flux tube provides around 2 terawatts. That is nearly 6 million times more power than the object's baseline output. This is the turning point, because if the fusion reactor was enough to sustain the system during transit, then Jupiter represents something entirely different. It is not a refueling station. The object does not need fuel for hundreds of millions of years. Instead, it acts as an external power source, one that can instantly scale the system's capabilities beyond anything it could achieve on its own. And this forces a new interpretation. The fusion reactor may not be the primary power source at all. It may be the equivalent of a backup generator, just enough to keep essential systems running until the object reaches a major energy node. Think of it like a ship crossing an ocean. During the journey, it relies on its own engines. But once it reaches port, it connects to a much larger infrastructure. The onboard power becomes secondary. The real operations begin only after connection. This idea explains several anomalies that could not be accounted for before. The trajectory adjustments, for example, those required energy bursts far beyond what 340 kilowatts could deliver in real time. If the system was storing energy during transit, then releasing it in short, controlled bursts, those maneuvers become possible. It also explains the absence of thermal waste. If the system uses an advanced energy architecture, one that stores and redistributes energy without significant heat loss, then the near-zero temperature readings begin to make sense. But the most important implication is what happens now. Because once 3I, Atlas connected to Jupiter's electromagnetic system, the energy limitations that defined its journey no longer apply. The object is no longer restricted to its internal output. It now has access to a continuous, massive external power source. This is where the mission changes phase. Everything before this point, the 8 months of transit, the controlled power output, the careful navigation, can now be seen as preparation. The object was not just passing through the solar system. It was moving toward a specific destination, a location where its capabilities could expand dramatically. And that raises a critical question. If 340 kilowatts was only the minimum required to remain operational and undetected, then what is the system capable of when powered at full scale? Because the data suggests something unsettling. The reactor was not running at capacity during the journey. It was running at concealment levels low enough to avoid detection by standard observation systems. Now, at Jupiter, that limitation may no longer exist. The system has reached its destination. The external power source is active, and whatever 3I, Atlas was designed to do, this is the moment it begins. If Jupiter is not a destination but a trigger point, then the next step is to understand the design logic behind 3I, Atlas itself, because nothing about this object behaves randomly. Every detail from its fuel composition to its energy output points toward deliberate engineering. Start with the fuel. The deuterium concentration inside 3I, Atlas is measured at around 500 parts per million. That number may seem technical, but its meaning is simple. It is far too high to occur naturally. The average interstellar medium contains only about 20 parts per million. To reach a concentration 25 times higher, the material must have been processed, refined, and enriched before the object ever began its journey. That alone tells us something critical. This is not a naturally formed comet that happened to behave strangely. This is a system that was prepared in advance, with a specific fuel load calculated for a specific purpose. When scientists ran the numbers on that fuel reserve, the result was almost impossible to accept. At the current output rate, the reactor could operate continuously for approximately 820 million years. That is not a mission timeline. That is an engineered lifespan. No human technology is designed with that kind of duration in mind. Even our most advanced systems are built for decades, maybe a century at most. But 3I, Atlas, is operating on geological timescales. It was not built for a single mission or a short journey. It was built to function across vast stretches of time, far beyond the lifespan of the civilization that created it. This leads directly to the next question: how is the fusion process being sustained? Because standard fusion, as we understand it, requires extreme conditions, temperatures of over 100 million degrees Celsius, to overcome the electrostatic repulsion between atomic nuclei. That is known as the Coulomb barrier, and overcoming it is the main challenge in all fusion research. But 3I, Atlas shows none of the expected signs of such a system. There is no plasma, no massive heat signature, no magnetic confinement structure. Instead, the data points toward a completely different mechanism, muon, catalyzed fusion. In simple terms, this method replaces the electron in a hydrogen atom with a muon, a particle that is over 200 times heavier. This reduces the distance between nuclei, allowing them to fuse at much lower temperatures, potentially even near absolute zero. No extreme heat, no massive reactors, no complex containment systems. On Earth, we know this process works. The problem is efficiency. Producing muons requires more energy than the fusion reaction returns, making it impractical with current technology. But if that efficiency problem were solved, fusion would no longer require massive infrastructure. It could be compact, stable, and continuous, exactly what we are observing in 3I, Atlas. Every piece of evidence fits this model. The near-zero temperature, the lack of thermal waste, the steady energy output, all consistent with a system operating far beyond our current capabilities. And then there is the final piece of forensic evidence, neutron activation. In any standard fusion reactor, fast neutrons interact with surrounding materials, gradually making them radioactive. This process limits the lifespan of reactors on Earth as materials degrade and become unsafe over time. A system running continuously for millions of years should show clear signs of this effect. But 3I, Atlas, does not. The gamma-ray spectrum shows only one specific line, the 2.223 MeV hydrogen capture signal. There are no additional signatures, no decay products, no radiation buildup. This means one of two things. Either every neutron produced is being captured and used efficiently before it can cause damage, or the system is continuously recycling and replacing affected material in a closed loop. Both possibilities lead to the same conclusion: this is not early-stage technology. This is a fully mature system that has solved every major problem. Humanity still struggles with fuel efficiency, heat management, material degradation, and long-term stability. Now bring this back to Jupiter. If a system this advanced was operating at minimal output during its journey, conserving energy and avoiding detection, then its arrival at a 2 terawatt power source changes everything. The fusion reactor is no longer the limiting factor. It is just one component in a much larger system. And that forces a realization that is difficult to ignore. 3I, Atlas was not built just to travel. It was built to operate, to perform a function that requires both internal energy and access to external power on a planetary scale. The design is too precise. The fuel is too refined. The technology is too advanced. This is not an accident. It is a system with a purpose. And whatever that purpose is, it begins here, at Jupiter. By now, the pattern is impossible to ignore. Every anomaly, every measurement, every piece of data points in the same direction. But there is still one question that has not been fully answered. Was 3I, Atlas, always this powerful, or was it deliberately holding back? Because when scientists reviewed the full timeline of observations, something unusual became clear. For 8 months, while the object moved through the solar system, its energy signature remained just below the threshold that would trigger automatic alerts in most gamma-ray monitoring systems. It was active, but barely visible, detectable only when specifically targeted, not during routine sky surveys. This is not how natural objects behave. Natural systems do not adjust their output to remain hidden. They do not operate just below detection limits, but a controlled system can. This leads to what researchers now call the throttle hypothesis. The idea is simple. The fusion reactor inside 3I, Atlas, was not operating at full capacity during its journey. It was running at the minimum level required to sustain navigation, system stability, and data collection, nothing more. That explains why the Fermi Gamma Ray Space Telescope only detected the signal during a focused 6-hour observation window. Without that targeted effort, the fusion signature would have remained buried within background noise. The system was effectively invisible, not because it lacked power, but because it was intentionally limiting it. Now reconsider the events that took place during those 8 months. The trajectory corrections alone required energy bursts far beyond what a constant 340 kilowatt output could provide. The object adjusted its velocity by measurable amounts while carrying a mass on the scale of 10 to the power of 13 kilograms. That kind of maneuver demands stored energy accumulated over time and released in controlled pulses. Then there were the other anomalies, the unexplained signals, the magnetic interactions, the synchronization effects observed across planetary systems. None of these fit within a simple, low-power model. They required a system capable of scaling its output far beyond what we were seeing. This is where the throttle hypothesis changes everything. If 340 kilowatts was not the system's maximum, but its minimum, then the entire journey of 3I, Atlas, can be reinterpreted. It was not just traveling, it was observing, measuring, and preparing. It was running in a low-power mode designed to avoid detection while collecting data about the solar system. And then, at a precise moment, the 18th of March 2026, it reached Jupiter. That is when the situation changed completely, because Jupiter is not just a gravitational waypoint, it is an energy source on a scale that removes any need for concealment. The Io flux tube provides a continuous stream of power measured in terawatts. Once connected, the system no longer needs to hide its activity. This is the moment the throttle opens. All the limitations that define the transit phase disappear. The stored energy, the internal reactor, and the external power source now combine into a single system operating at full capability. And when you connect all the data points, the picture becomes clear. The 847 gamma-ray photons detected at 2.223 MeV confirm active fusion. The enriched deuterium fuel confirms intentional design. The 8-month operational window confirms long-term stability. The lack of thermal waste confirms advanced energy management. The trajectory corrections confirm stored energy release. Individually, each of these observations is extraordinary. Together, they form a coherent system, one that was never meant to be fully revealed until it reached its destination. Which brings us to the most important realization of all. We have been asking the wrong question. For months, the focus has been on what is powering 3I, Atlas. But that question has already been answered. The gamma-ray data made it clear. The real question is what the system was doing during those 8 months, and what it is about to do now. Because if the object spent its entire journey in a low-power observational state, then its arrival at Jupiter marks the transition to its operational phase. Not travel, not observation, operation. And that means whatever function 3I, Atlas was designed to perform is not in the past. It is happening now. Now everything comes together, not as isolated anomalies, not as disconnected observations, but as a complete system revealing its purpose step by step. 3I, Atlas was never just an object passing through our solar system. It was a mission in progress. Look at the full sequence one more time. The fusion signature detected with overwhelming statistical certainty. The enriched fuel prepared long before arrival. The 8-month transit phase operating just below detection thresholds. The stored energy used for trajectory corrections and system-level interactions. And finally, the precise convergence with Jupiter's electromagnetic infrastructure at exactly the predicted moment. None of this is random. None of it is accidental. It is a timeline. During its approach, 3I, Atlas behaved like a survey system. It observed Earth, interacted with planetary fields, and collected data across multiple layers, magnetic, gravitational, and possibly even deeper structures we are only beginning to understand. Every action was powered by a controlled, low-output fusion system designed to remain hidden while still performing complex tasks. Then came the transition point, Jupiter. At that moment, the system gained access to an external energy source thousands of times greater than its internal baseline. The Io flux tube did not refuel the object, it amplified it. It provided the power required to do something the internal reactor alone could not sustain at full scale. And when you consider what requires that level of energy, one possibility stands above all others: transmission. Because sending information across interstellar distances is not a trivial task. It requires enormous power to ensure the signal can travel light years without degrading into noise. The stronger the transmission, the clearer the message, and the farther it can go. Now think about the direction of 3I, Atlas's trajectory. It is not random either. Every model points toward a region in the direction of the Gemini constellation, approximately 180 light-years away, that is not nearby. That is deep space communication range.